Okay, microphone's over there, right?
Should start soon.
No, I think we started. We are live. Hello,
Maybe.
everybody.
Wait for it.
Okay.
There it is for life.
Okay. Okay, good evening, everybody. This is Doug Solisey, and
I'm Vivek Vijay Kumar.
And we're both up here in Julian at Curiosity Peak, and we're going to take you on a stroll through the cosmos, starting with the big picture of the sky through an all-sky camera. So that covers a big part of the sky. We could talk a little about the constellations that are up there.
Yeah, so I'll give it one more second to load. Okay, here's the bigger picture view of, let's get stretching. So this is obviously this is the Milky Way, and a little too much. 100%. Okay. Yeah. Well, we'll allow some people to you still got 2 minutes. So, but oh wait, I can see Andromeda here.
Yeah. Oh, nice. Really? Okay, that's Andromeda.
Yeah, Andromeda's in the all-sky cam. But yeah, we've got Lero. The main problem right now we're having is all of the hot pixels.
Yeah, I see the kind of Christmas colors there. Yeah, those bright green and bright red stars are actually not stars, they're hot pixels. And that's just the way of the sensor telling the world that it's not perfect. But that's okay.
Yeah, we have to keep the gain up.
So we're just one day after the new moon, so there's probably there should be a crescent moon hanging in the west. We can't see it from inside the observatory.
Oh, you can see
It's low.
You can see the North America.
Yeah. Okay.
It's in the corner, top left.
Well, maybe we could preview some of the things that we'll look at through the telescope. And one of the things we want to do by using the all-sky camera is to enable people to do binocular astronomy, because once you know your way around the sky just a little bit, you can really get out those binoculars and see some of the things that we're talking about and showing you. You may not be the same view as through a telescope, but you can see them, and that in itself can be pretty exciting, especially if you're out with friends and family and you can share it.
Yeah. Okay, so it's in the corner. So I guess I'll start with the overview, right? So let's see, 100%. Okay, it's kind of hard to tell because there's just a lot of stars and there's a lot of hot pixels, but in general, this star right over here, that is Vega, and that's the constellation of Lyra.
Is your cursor showing up? I don't see it up here.
Hopefully it is.
Oh yeah, I see it. Yeah. Yeah, it is.
Okay, and then over here we have Deneb. That shows right. Yeah, we've got Deneb over here, and we got Cygnus the Swan. And over down here we have Altair, and that's in Aquila the Eagle. And we've got also over here, I don't know, it's kind of hard to see. Let me enlarge that. It's a little too much. Over here we've got Cassiopeia, it looks like a little W. And over here we have the Andromeda Galaxy over in the corner.
Yeah, M31, our galactic neighbor.
But entire overview, Milky Way.
Yeah, and that's the Great Rift in the center.
Yeah.
that dark area is not where there's no stars. It's just, in fact, there's probably just as many stars, but there's dust, clouds of dust there, some of the raw material of our universe that's blocking some of the stars in that area. So the Milky Way isn't homogeneous. It's got all kinds of different areas where dust is concentrated, some areas where stars are forming, areas with clouds of gas. It's a whole massive activity and variety.
Okay, and just to be clear, let me show the what we're using. That's okay.
I'm gonna give you a little peek at the equipment.
That's the all-sky camera. So it's just sitting there on top of the observatory.
On the wall, right there.
Yeah.
That was taken, of course, during the day.
Yeah.
Just as the sun was going down, in fact. You can see that.
So it's a very cheap webcam and a little lens, all-sky lens on it.
Yeah, amazing little camera, though. We'll use it to look at Mars later.
Yeah.
Yeah. Okay, so just so people know, okay, we got some people kind of signing in. Hi, Rick, from rainy Sequim, Washington, between Port Angeles, Port Townsend. Chip and Lynn, hi, guys. Okay, and we've got S.V. Kumar. That sounds familiar. That might be your mom. Okay, all right, and let's see. That was Rick and Rick Pinson from Long Beach, California. Cool.
Okay, the constellations are a little clearer now that it's stacked more. So I guess we can recap a little bit. We've got Deneb over here in near the top left. We've got Vega, and it's like a little. It's like a little rhombus over here, and we got Vega. Then all the way over here we've got Aquila. We got Altair in Aquila the Eagle.
And even if you're in the city, you should be able to see those three stars. And
there's our dinky view of Andromeda.
Okay. Yeah, and that's the summer triangle. It's kind of like the Big Dipper. It's an asterism. It's a pattern that is easily recognized and helps you get oriented. Those three stars that are always right there around the Milky Way, the summer Milky Way.
Yeah, it's a pretty good view.
All right, Rhonda. Hello, Rhonda and Kevin. All right. And, Kevin just got some great nightscape pictures down in Campo, which maybe we'll be posting some of them on our
website.
Yeah, at Facebook. Okay, all right. So are we ready to get going on our tour, do you think?
Sure, we'll have to. A very quick intermission.
Okay, we're gonna now connect from. Work is connect to the all sky camera, so we're gonna connect to. Want me to get it for you?
Well, let me. While we're looking, I'll just look at the wide field view of Cocoon right now.
Okay.
We'll use that for intermission.
Okay, we're gonna have a little tiny break. Not long, a minute or two, just to connect from the all-sky camera. We're going to go to the telescope. So we have to connect our computer to a different device, which is a camera on a wide-field telescope. When we say a wide-field telescope, it means it has a short focal length compared to the size of the lens. The lens is 61 millimeters, which is just about 2.5 inches in diameter. Not a huge telescope, but it's short and stubby.
We can show it. Okay, now we have the live view of whatever it's pointed at. Oh, it's okay.
Is it pointed where we want it to be?
Yeah, it is.
Okay, that's
so
good
let's
news.
show what we've got.
All
and
right.
it's a very small little refractor for sure. in the observatory.
But it's an APO, it's a triplet, so it's got very good quality optics, which is great for, we're using it now for live viewing, but it's also good, and it will be used for astrophotography, just the way it looks right there.
Yeah, okay.
And that's a color camera that's on the tail end of it. That other telescope that's perched on top is a guide scope. That's for giving it precision guiding, which we're not too worried about right now.
Just let it take an exposure.
Okay. So how long of an exposure are we going to take?
Just 30 seconds. It's almost done.
Okay, so what are we looking at? This is VDB 126.
Yeah, if we did this last time in our last star party. But we're going to show it with a different, more wide field view of it. If I can get it to show.
And this was an area that had some dark nebula, right?
Yeah.
As well as reflection nebula?
Yeah.
Hi, Mike McKeague up in Oregon. Good hearing from you. Glad you could be with us. And Roger Monroe from Missoula. Okay, Lynn and Chip want to know about Vega. Vega is a star. It's a blue star, which means it's hot, and it's quite bright. It's also, if anyone's familiar with the book or by Carl Sagan, Contact, or the movie with Jodie Foster, that's where the signals were coming from that meant there was some intelligence out there. So Vega's definitely a star worth noticing. It's one of the brightest stars in the sky too. It's not a galaxy. It's a what we call it, a resident of the Milky Way in the constellation Lyra. Lyra being the little musical instrument, kind of like a harp.
Okay, finally it's doing it. See if Sharp Cap will be generous.
Oh, you're using Sharp Cap? Not Nina.
Yeah, we'll see.
Okay. Okay, there's different, we're just talking about a software that both to control the camera and tell it how long and how many exposures to take.
Okay, this software is not working well.
No? Okay.
We'll just change software.
Switch over, we're going to switch over different software to Nina. Ooh, that's a nice picture.
Yeah.
You may see a great shot of the Orion Nebula here in a second.
I love technical difficulties.
Okay, we're gonna use a different software here, Nina, for both capturing the images and presenting them on the screen.
Let's get this.
There's that beautiful lavender screen.
I've already seen it.
Yeah. Oh, there's the Orion Nebula.
Okay, we'll try this instead.
This is what they're seeing, right? Yeah. Okay. There's a little lag between when we capture something and it's on our screen and it's on your screen. We have a second monitor and set up, so we are kind of also seeing in sync with everybody out there. Okay.
This is going to be hopefully more generous. Okay, that's much better than whatever Sharp Cap decided I wanted to do. That's pretty good. Okay, so this is VDB 126.
Well, hi, Betsy from Borrego Springs. Super glad you could make it with us. And Ernie and Katie Cowan.
Okay, so this part over here, this is VDB 126.
Okay, in just a second, there it is. You're seeing what's called...
So this is VDB 126,
Mm-hmm.
and I'll just take a little longer exposure, but it's within this lots of these different dark nebulae scattered across the Milky Way and the Great Rift. So, and then VDB 126 specifically refers to a reflection nebula in these inside of the dark nebula, which hopefully we should see soon. But yeah,
Now, how big of an area, what's the field of view there that we're looking at?
this is probably a couple of degrees.
Okay, which
Probably
is,
probably 4 degrees. It's a very wide field
Mhm.
telescope we're using. Okay, we got a much nicer exposure. Okay. Yeah, so this wide field really allows you to look at lots and lots of different stars across the field of view, and large swaths of dark nebula.
and that's in Cygnus?
Yeah.
Yeah. Yeah, Cygnus is a really rich area of the Milky Way, and all kinds of nebula, a lot of stars, dark nebula. Good place to go with binoculars. And
Yeah.
remember, you can find it by finding Deneb, which Deneb is the tail of the swan. So it's one corner of that summer triangle.
Yeah.
All right, Elizabeth from
Okay.
Borrego Springs, welcome.
All right, are we ready for the next target?
Mm-hmm.
We're gonna wait a couple of minutes. If anyone has any questions about what we're discussing, then make sure to put that in the chat. Okay, I'm just making it take 2 minutes now.
Mm-hmm. How long are the exposures? 2 minutes?
Yeah.
Okay, we're taking 2-minute exposures,
Then we'll after that. This one we'll move on.
and these are just single shots, so it's not really that complicated. And we're not auto guiding.
No.
Okay. The nice thing about a wide field short telescope is that you can do imaging with it through the telescope, and the guiding doesn't have to be absolutely fabulous because it's a forgiving format.
Yeah.
So it's a good way to get started if you're going to do astrophotography. And some of us have started with long focal length telescopes and
That didn't work out
had
very
tremendous
well for them.
difficulties and challenges. So definitely a better way to start. Okay, when you see a line going across the photograph, is that a meteor, satellite, or an aircraft?
Can be either of those three.
Okay.
I remember seeing those streaks you're talking about, and I actually don't know what that was because I don't remember.
I don't think it didn't look
I
like
just
a
kind of
meteor.
ignored it.
Yeah,
If there's multiple streaks, it's probably an airplane. We have quite a lot of those going over right now.
yeah. The planes, there's usually a broken, kind of like a dotted line when the.
Well,
If
there can
it's-
be like 3 streaks at once because of all the taillights.
Yeah,
So, really depends on the pattern. Then you can tell what.
and there are
what
lots of them up there. That's for sure.
Yeah.
They.
Oh,
Yeah.
that's really nice. It's 2 minutes.
Yeah. Now you're seeing the dark nebula is showing up a lot more. Okay, with the 2-minute exposures.
We're getting a little trailing. Yeah, I can see that
Mm-hmm.
the stars are trailing a bit, but
Yeah.
good enough
Mm-hmm.
without any guiding. Yeah. What are we looking at currently? This is VDB 126, which is this thing, which is a reflection nebula within this large swath of dark nebulae in the Great Rift of the Milky Way,
Mm-hmm.
which we looked at previously in the all-sky cam.
Yeah, which you can see with your eye. If you look at the Milky Way, you just see it seems to split right there in the two parts, but it's really not two parts of it. It's just that there's some dark dust there in the Milky Way. That's
Yeah.
a huge amount of dust to be blocking a lot of stars. But then there are stars that are in front of the dust, and those are the stars you see in those dark areas.
Yeah.
Say those are foreground stars. One of the things that's challenging is to try to put yourself into a three-dimensional mode of looking at the sky, and get a sense of what's closer, what's farther. Like when we look at the great galaxy Andromeda, we're looking almost like out through a little window 2.5 million light years away at another galaxy.
Okay.
So don't always bring your imagination with you when you look up.
I think we can move to the next target.
Okay, all right, we're going to move on to the E Nebula,
Oh boy.
B142.
That's another fun one.
Yeah, okay. These
More manual coordinates for me.
Okay, this is not one that's real commonly known. We kind of mix things that are lesser known with things that are kind of iconic.
I'll let you see this us slewing.
So Vivek is going to navigate our celestial vehicle to get us over there. You'll hear the engines roaring in just a second.
Okay.
Well, almost everything we're looking at tonight is within the Milky Way, with one exception. And we're going to look at one object that's within our solar system.
Okay.
Sometimes called the red planet. Hopefully you can hear us okay. If you can't, let us know.
Okay, it's going there.
Okay, we
Should be somewhere there.
fired up the engines. You'll see some streaks on the screen that show how fast we're moving.
Should be there now.
Okay.
Well, can't tell with 1 second exposures. We'll take 30 and we'll just keep going up from there. And this is also another dark nebula near Altair.
Okay, we'll talk that. Okay, we're at 32 viewers now. Okay, thank you, Rhonda, for the feedback. Rhonda says we're loud and clear. Good. Okay.
Stream is healthy again. Good. No more buffering.
Okay.
There it is, finally.
All right.
This was elusive in the last star party, but now it's actually here.
And gee, can anyone guess why it's called the E Nebula?
Let's jump up to 2 minutes for this. We'll let
That was the first exposure.
Yeah, the first 30 seconds. And we have a satellite here.
Okay, yeah, another intruder.
That's definitely a satellite.
Okay.
Looks like it might be even tumbling because it's inconsistent.
Oh, yeah, it's brighter and dimmer. And
yeah, so that means that the satellite might be tumbling, which means the brightness changes as it's transiting. Lots of stars. We're still in the Milky Way.
We are definitely in the Milky Way. You can tell by the density of stars.
Yeah.
But clearly a very dark outline. Almost looks like a branding iron was used there.
Yeah.
So these dark nebulae are very interesting, but you've got to be in a place with a dark sky to be able to image them or try to glimpse them. If you have a telescope, it takes a larger telescope to really see things like that, but it also takes a dark sky.
Yeah.
So we're very happy to be here in Julian where we can do this kind of thing and share it with people, and certainly invite everyone to help us reserve it. Okay. Wanda liked that star. I'm not sure which star she meant. But... How do you turn on?
The screen brightness off.
Oh, just turn it off completely or down?
No, just down.
Let's see, I think...
Okay. What is the bright star below left of the nebula? To be honest, I don't know.
Okay.
Looks like it's orange, so it's probably a G to K type star. Oh, 2 minutes we've got trailing. It's a G to K type star. Don't actually know exactly what star that is, but it's just a typical star in the Milky Way. Yeah, that looks much better.
Well, let's see. Use the mouse to do this.
No, you have to use a toggle.
Okay.
Okay.
No, I tried. Okay, so are we going to move on to North America?
I guess.
Okay, remember people who were with us last Saturday, we looked at an area that was called the Great Wall, I think.
Yeah.
Okay, it was pretty interesting, but it was just a part of a larger nebula called the North American Nebula. So since we were looking through a longer focal length setup, we were able to zoom in on that particular detail, which was pretty cool. But now we're zooming out since we have a wide field setup, and we're going to see the North American Nebula more. I don't know if I say in its entirety, but
Yeah, in its entirety.
okay. You want me to?
Yeah, turn the screen brightness down.
Yeah, I was trying to.
I think it's affecting that.
Okay, how would you do it now? Well, let's see.
Press the left button. Okay, it looks like we've arrived.
Okay, now what?
I'll
See, I've
just-
got this.
The other way.
Hmm?
The left button.
To the left?
There we
Okay,
go.
and then what?
Hold left. Other button.
Okay.
Up. There we go.
Okay.
Okay, we're gonna take a 30-second, and we'll do a 2-minute on the North America. Roger the world. Okay.
Okay, how far should I dim it down? About like that? All the way?
Yeah. Yeah. Just hold it.
There?
Keep going. Yeah, that's good.
And then what? Just
Yeah. Okay. That's fine. Okay, we're almost. Exposure's almost done. Okay. So it may have it didn't exactly center it. Okay, so I don't know if people can see, but that's the outline. So this would be the Gulf of Mexico over here. That's Florida, the East Coast, and that's why it's called the North America. And that's Mexico, and then there's Central America. So that's the North America. It becomes a little more clear as we get a much more. Well, let's get a longer exposure.
yeah,
on
we're,
there.
okay, we're going to get a 2-minute exposure?
Yeah,
Okay.
but I think there is the North America.
Mm-hmm.
What
Yeah.
live stacking program we're using? We've chosen for this star party to stop using SharpCap for live stacking, and instead we're just taking long exposures with Nina. So it's straight up taking 2 minutes. We're not doing any kind of stacking. Mostly because we don't want to pay for SharpCap auto stretch. Nina has auto stretch built in, which means auto stretch means like doing processing to show the image in good quality.
Right, to increase the contrast.
So people can see,
and-
because otherwise, if it's unstretched, it looks like this. This is what the raw data looks like. It's just mostly black because these objects are very faint and you have stars. But if we stretch it, and that's what we're doing here, then you see all of the detail in the image. So, in SharpCap, people probably noticed this, but at the bottom right, we're messing with the histogram sliders to try to get it. And it's never good. So, for this star party, we're going to try out just using auto stretch and Nina. So,
Yeah.
that hopefully makes things easier. Only downside is there's no live stacking, but
Mm-hmm.
for
Yeah.
this setup, that's okay because It's wide
Is
field.
that Deneb right there?
Yes.
Okay, yeah, yeah. Chip was asking what that bright star is.
No, he was asking about the other
Oh, yeah,
on
before.
VDB one.
Oh,
No,
okay.
in E Nebula.
Okay,
Yeah, but that is Deneb here.
that is Deneb. Okay, yeah, that's that star that's the tail of the swan. Okay, yeah, Christopher, glad you could make it from Borrego Springs.
Well, no, this isn't Deneb. But Deneb
That's
is
not-
in the.
Oh,
Deneb is
it's,
off to the left.
okay, it's to the left. Okay, that's
It's
just
not
a,
in the image.
that's yeah, that star isn't bright enough to be down.
Yeah.
But it's brighter than the other stars. But
Okay, that's a
Okay.
much better exposure.
all right, now we're seeing some color.
Well, you can see the outline more clearly. This blotch over here, that's called a pelican.
Mm-hmm.
Bec-
Yeah, there's the beak of the pelican.
Then we have the Cygnus
The
Wall,
long
which is what we're looking at last Star Party. And we've got the Gulf of Mexico, essentially.
Yeah. Okay. Where's okay? Can you show the Cygnus Wall again? The Great Wall.
That.
Okay. Yeah. And I think it was at maybe 90 degrees, right? The orientation different when we looked at it.
Yeah.
Yeah.
But I think this is
Or sort of Central America, if you want to, you know,
geography.
right?
Geography.
Look at the North American Nebula, Mexico, and then it kind of disappears after Central America. Yeah, South America is absent for some reason.
No,
Okay.
this is just the North America.
Yeah. Well, anyway, our human imagination runs wild when we look up at the sky, as you can tell by all the names
Well,
for things. that
there's
have been
Florida.
adopted. Yeah. Mm-hmm. Okay.
I
Yeah.
think we can.
Mm-hmm. Okay. So Rhonda says they're viewing it on a computer and a TV screen. Wow. Computer is so much better quality. Yeah.
We could. If we can move on to the Seder.
Okay. Seder. Okay. And Seder's in Cygnus, right?
Yeah.
Yeah.
So we'll change this back to 1 second exposures.
Maybe wondering, why are we spending so much time in the same constellation? Well, there's a lot of good stuff there.
Well, this I'm just gonna go to the star
Yeah.
and see what's there.
Okay.
I don't know. Hopefully it's bright enough.
Mm-hmm.
The nebula.
Seder is the same as Gamma Cygni, right?
Yes.
Yeah.
Gamma Cygni Nebula, Seder Nebula, etc.
Mm-hmm. Yeah. Gamma, alpha, beta, gamma is used with talking about stars and their respective constellations. Alpha usually refers to the brightest star in the constellation. And then beta would be the second, and then gamma the third. Occasionally they're not because somebody made a mistake, but generally that's what they refer to. And then they often, the brightest stars have names, Greek, Arab names that have been, passed on and adopted.
Well, I'm seeing pinks and oranges in North America. So then North America is mostly actually red, and the colors are not quite right with just looking at raw data from a color astronomy camera, but it's actually red. But that red signifies hydrogen alpha, emission from hydrogen in the nebula, because the nebula is lots of the nebula we're going to look at today are just made of hydrogen, and they emit hydrogen alpha, which is 656 nanometers, and that produces the red color.
And that's ionized hydrogen?
Yeah. And these kind of cameras, they have a green bias. So mix that red with green, and you get an orange bias. So that's why you're seeing the colors you're seeing. But these are, in fact, red. Just
yeah, when we process images, we're able to, bring out real colors and get rid of the colors that come from atmospheric aberration.
So this is the Seder region, and here's Seder, the star, or Gamma Cygni.
Yeah, there it is. That one is.
It's in the middle of the cross.
Okay.
That makes a Cygnus the Swan.
That's Gamma Cygni, so it's the third brightest star. Deneb being the brightest in Cygnus.
And then, I think it's Gamma Cygni. Yeah, you're right. Yeah.
Deneb would be Alpha Cygni.
Deneb is Alpha Cygni.
Yeah. Right. Okay, Roger wanted to know the focal length we're using, about 270, 260?
Yeah, we're using 274 with this 61 millimeter aperture telescope, baby telescope essentially.
Yeah, it's a little guy. And it's got a reducer on it, which makes it even wider field and shorter focal length.
Yeah.
But it concentrates the light more, so the image is brighter, and you can get an image faster.
Yeah. So this is the Theta region. If you noticed, there's your nebula from hydrogen alpha emission. Then you have all of the stars in the Milky Way, and you have a dark nebula that goes right between the nebulae. So it creates this effect of having a mission nebula thing crisscrossed by dark nebulae. So, well, 2-minute exposure will show this a little more clearly, hopefully. Yeah.
Is there the same lag for a voice as the image? Oh, okay. So they're seeing that now. Okay. Yeah. So that's the dark area right there that Vivek was just talking about.
Our sound is paired with what's here.
Oh, okay.
Ignore that.
Oh, okay.
Just ignore that.
Yeah, okay. That's what I was asking, yeah.
Okay, so...
All right.
Well...
Yeah, so that's a really intensely red when you get stacked a lot of images, hours and hours of images. It just all jumps out more, and then we process it. And okay, yeah. And we have, if you want to see what some of these things look like, go to Curiosity Peak website, and that's curiositypeak.us, and we have image galleries showing, where we've, done hours of imaging and processing, and see what these things look like when they're really done.
This is only 61 millimeters aperture, and we're getting a lot of detail.
Yeah, and 2-minute exposure.
Yeah.
Okay. So.
We're almost done. It's all reaching 2 minutes. We got 12 more seconds.
Oh, we haven't got the 2-minute.
Yeah, we haven't gotten the 2 minute yet.
Okay, it's coming.
This the one on the screen is 30 seconds.
Yeah, and you can see just between 30 seconds and 2 minutes the difference. So then when we multiply there we go. Yeah, see the contrast is a lot stronger.
Yeah, very nice contrast. This is a very these nebula are pretty faint, so this is a pretty effective way of getting the good image out of them. They don't have too much trailing, it's a little bit.
Yeah. But
no guiding. Just
if we had the auto guiding working, there wouldn't be any trails. But the trails are only noticeable when you blow up the image.
Yeah, just don't look too closely.
Yeah, right. Don't put the magnifying glass away. Okay, so we're going to move on to the Veil Nebula.
We've done this before.
Okay.
But only with a small field of view. Okay,
now we're going to see the Veil Nebula, which we looked at previously, but we're going to be stepping back and zooming out. So this is the remnant of a supernova for people who haven't seen it before. It's one of the most striking supernova remnants. In other words, this is what the filaments of gas that are left after a supermassive star literally blew up and scattered its gas all over, okay? And the interesting thing about the supermassive stars is they don't go as long as the smaller stars. They have a shorter lifespan, kind of a burst of glory at the end.
Yeah, I'm going to center this because I want to show the entire nebula.
Yeah, okay, sure. And this is a really large area that this supernova remnant covers in the sky. You have to have a wide field to get the whole complex of nebulosity into the picture.
Okay, we'll take a 30 seconds and do it, 2 minutes.
Okay, so the 30 second will give you a sneak preview of what it's going to look like in 2 minutes.
Yeah.
Yeah, we just want to thank Betsy Kanak for putting our star parties in the ABNA newsletter. Really glad to be able to connect with people out in Borrego Springs and other areas that get the newsletter.
Okay, 30 seconds is almost up.
Okay, we're all going to see the 30-second exposure first.
Bruh.
Whoa. What happened? Okay, it was still slewing? or what?
I have no idea, but we need it. It might be wind.
Hmm?
Let's
Really?
fix this.
Okay, well, you're going to see a whole bunch of star trails in a second, and that is not what we're, yeah, okay. Mm-hmm. Okay, now it's looking a little better.
Well, this is just 1 second.
Okay.
Well, we got the entire nebula in here.
Mm-hmm. 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 Okay. So you're slewing a little bit to
Center it.
okay. The reason the image is we're getting some trails because we're moving the telescope to try to get everything within the field of view. In other words, we're framing the shot.
Is tracking off or something?
Shouldn't be.
Something's.
Really?
Yeah, it's not doing EQ north. Yes, it's correct.
Well, wait. Has it hit the? It hasn't hit its limit, has it?
No, it's on the other side of the meridian.
Yeah. Yeah. Right.
Okay, now it's up and it's stabilized.
Okay.
So we'll now take a 30 seconds and then we'll do 2 minutes. If it's not stabilized, then I don't know what to say.
Problem is.
Actually. Let's do this. That DSLR is doing work.
Mm-hmm.
Yeah.
Yeah, I hear it chirping away.
Okay, it's almost done with 30 seconds. No trails, please.
Okay, all right. I think we're starting to see something here.
Okay, that's the entire. Yeah, we see it now.
Okay.
We'll take a little longer though. We'll take a 2 minute. But yeah, this is the entire region. You can see this is the Western Veil Nebula. You see over here. And this is the Eastern Veil Nebula on the left. So that's the Eastern Veil. It's the Western Veil over here. And then we have this little middle portion. You can barely see it. It's called Pickering's Triangle. But this entire complex is a supernova remnant from a star a few thousand years ago. And it's spread across like 3 degrees of the sky. It's a very large.
Mm-hmm. Which
But
is
we
like
have
six times the diameter of the moon.
Yeah, but we have enough. We have a wide enough field to get all of it in here. But since we're just doing broadband, you can only. It's pretty faint. If we were taking it in the specific, if we were using hydrogen alpha filters that isolate the specific lines from the emitted by the nebula, oxygen 3 and hydrogen alpha, then we would see this a lot more in contrast.
Yeah, the colors would be more vivid.
Yeah.
Yeah. Now that's the witch's broom over there on the right. Right?
Yeah, that's Western Veil Nebula.
Yeah, sometimes called the witch's broom because it looks kind of like a broom, but maybe a little bit handmade. Straw with a bright star in it, which is, what is that bright star that's in?
That's 52 Cygni, I think.
Okay.
Doesn't have a proper name.
Okay.
And that's so that's the entire complex.
Any questions about the Veil Nebula or comments?
Yeah, because in previous star parties we've only gotten like that much of the Veil Nebula, but it's all of this. It's not just this specific portion. That's the beauty of wide field. Oh, we got a much better exposure now, with some trailing, but.
Oh, we got the 2 minute first
Yeah.
one? Okay, yeah. Now we see a little bit more color, blue and red.
Teal and red, I would say.
Teal and red, okay.
Yeah. Okay. All right, I think we can move on.
Okay, we're going to head out and check out the Iris Nebula, which is NGC 7023. Okay, so we're going to fire up the engines again. You'll hear, there it goes.
Wait, I didn't loop.
No.
Okay, now we'll see the trailing.
Trails, okay.
There we are.
Well, it just gives an idea of the warp speed we're
Where is the
traveling
Veil
at.
Nebula in the Milky Way? The Veil Nebula is in like it's in Cygnus. It's, if you think of a straight line between Deneb and Satyr, it's below that. So it's in one of the wings of Cygnus the Swan. Yeah, so everything we've been looking at has been in Cygnus until now. Almost everything.
Okay, is the very fine granular material in the nebula dust or small distant stars?
What do you mean by granular material? First thing you have to recognize is there's a lot of camera noise. So, but yeah, it's in the Milky Way. There's a ton of stars. The nebula isn't very bright, so it doesn't really come off in the stars, and we are only taking a few minutes of exposure time. So there's a lot of noise. So all of those, I think, are contributing to what you're seeing, but I'm not exactly sure what you are referring to.
Yeah. I mean, there is dust, around in most nebulae. But the graininess is from the camera. Now, you might want to know, how do you get rid of that graininess? Well, you take a lot of exposures and stack them up, and then the graininess, the things that we don't want that come out of the workings of the camera kind of get minimized or overshadowed by the actual features of the target, because whatever we're shooting a picture of, that light is coming consistently, hitting the same pixels again and again and again.
Can you easily switch to Sky Atlas view? If you want to see, we can open up Stellarium really quickly.
Okay.
That'll show.
Okay, Eleanor Schubert in Carlsbad. Hi.
Okay, let's Cygnus, because that's basically where we've been going. So there's Satyr region from before, and then here's the North America and the Pelican, upside down, but you get the idea. Then down. So these are the three you've been looking at, and there's the Veil Nebula. And there's a lot of faint detail there that we obviously couldn't get because we were only taking a few minutes in broadband.
Yeah, these images were taken with considerably longer or more exposures, longer.
Yeah, but this entire, let me show the constellation lines. That's Cygnus the Swan. And there's basically a cross, and then it has the wings.
Yeah, the Satyr's right in the center.
And then the E Nebula, which we were looking at earlier, is near Altair, one of the stars of the Summer Triangle. Here's the Summer Triangle.
Right, in Aquila.
And then this is the E Nebula.
Okay, so it's kind of on the border.
It's near Altair. The VDB 126 is in a little part of right in the smack in between Altair and Vega. So that's where we've been lately.
Yeah.
Now we're in the Iris Nebula, which we've just arrived to. That's in a completely different part of the sky, near Cepheus the King, and we're going to be looking at this. So let's switch back.
Yeah, I really encourage you, when this is over, go outside, see if you can identify at least the Summer Triangle and kind of orient yourself with the Milky Way.
But yeah, here you can see the Iris Nebula. It's a reflection nebula. It's got its blue color. And then if you notice, there's absence of stars over here and over here. There's quite a lot of dark nebula all across this image. And hopefully we'll see some more of that with the longer exposure. But
Okay, Susan Sandwell is comment. Within the West and East Veil Nebula, I think, the image looks to me like bright dust. I understand the whole screen
Well,
appears granular,
the looks
ask
like
about
bright
the lighter
dust. The
background
nebula is
in the
gas.
nebula. Yeah.
The nebula is gas. It's made of what you're seeing is hydrogen and oxygen, doubly ionized oxygen, which emits that teal light, and then hydrogen gas, which emits that red pinkish light.
Mhm.
So those are the two things you're seeing. They're gaseous parts of the Veil Nebula. Can these nebulae be distinguished visually with the 61 millimeter? Do you mean if you can see?
If we put an eyepiece.
If we put an eyepiece, yeah, 61 millimeters is. I mean, if you were, I've seen reports of if you put if you put a filter called the ultra high contrast filter, which filters only the wavelengths from the nebula, you can see the North America and those nebula.
And especially if you go to a place that's really, really dark,
Yeah, that's a
then
requirement.
everything becomes possible that it wouldn't be even when I say really, really dark, I mean darker than Julian. For instance, if you go down to Baja California, or get away from the border, and get into some of the remote areas, or get out to Death Valley.
Yeah.
There's White Los Pinos and White Mountain. There's places in California that are very dark, but you have to go 3-4 hours or more to get to them.
But yeah,
and then you probably could see the North American nebula.
No, well, you can see the North American nebula with the 61 visually if you have that filter.
Okay.
But
like
even here,
Julian,
yeah. But you can't see the Iris, you can't see the E nebula. All those are all
the dark nebula.
These are the 61 millimeters more advantageous for photography purposes, not visual.
Yeah.
For visual, you want lots of aperture so you can get lots of light because our eyes are not that sensitive. So we need lots of light for these nebulae to become visible, and we need to filter out background, quote unquote useless light, like that isn't from the target, and that will allow us to see it even more in high contrast. So the answer is no, not really.
Yeah.
This is really this is a photographic telescope. So
it's small. It's very portable. Larger telescopes are
a
little more difficult.
Let's look at the image. It is very tiny.
Yeah.
But anyways, you've got the Iris. We got 2 minutes now. You can see a lot more of the dust. And we've got a portion of another reflection nebula, which is called the Ghost Nebula. Doesn't really show that well, though. You'll need hours of integration for that to develop. But, yeah, pretty nice image.
So the Iris Nebula, as you might guess from its name, is pretty bluish.
Yeah. Okay. All right. We can VDB 145. I think we can go to the next target.
Okay. Yeah, one thing about a small telescope, though, if you put a camera on it, you can do a lot with it, which is what we're doing. But then you need to have a mount that can track, the sky as the Earth turns. Okay, so we're going to head over to the Dark Shark. That sounds pretty sinister. The Dark Shark Nebula. VDB 145.
Okay, let's show where that is.
Okay.
It's another part of Cygnus.
VJ Kumar wants
Cepheus.
to know which of these nebulae can be seen through binoculars.
No, short answer, if you're in dark skies and you have no filters, you just have binoculars, none of them, because these are not very bright nebulae. Technically, if you had the filters for the North America, you could see that with binoculars, but no, these are pretty difficult targets.
And most of them are, some of them are smaller too. But
yeah, they're pretty small too.
But you could the richness, the rich field, what we call a rich field, where there's just thousands of stars, that really does jump out when you take a pair of binoculars and sweep across the Milky Way. And in the summer Milky Way, in this constellation Sagittarius, there are some nebula that you can see with binoculars, such as the Lagoon Nebula.
Yeah.
And you can also see the great the galaxy and Andromeda very well with
Yeah, that we're
binoculars.
gonna. I think we're gonna visit that soon. So
Yeah.
that is a binocular object. That's
Yeah.
even a naked eye object too.
Yeah, you
Here
can,
in Julian.
in a dark place like Julian, you can see it with your naked eye. You have to kind of know where to look, but it can be seen. And, 7x50 binoculars are quite adequate to see it, and a lot of other things. Also, we're going to look at the double cluster. That's a good binocular object.
That's also naked eye.
Yeah.
Okay, we've arrived. We'll see.
Okay, we are at the dark shark now, which is lurking in the shadow, so we're going to have to take a longer exposure to see that shark. I guess we're doing 30 seconds.
Yeah.
Is that enough to see it?
We'll see.
Okay.
If it isn't, it'll take 2 minutes.
Okay.
You should see something at least, though.
Mm-hmm.
Hopefully. It's also trying to extend our range to much more fainter objects, which is why we're taking these. Drop the... Great, that's nice.
Okay.
Okay, we'll have to. Okay, we'll have to try
Is
that
the
again.
wind?
No idea. Let's see what... If we take 1 second, we can see what's going on. Where do we look in the sky to see these nebula? So, most of the ones we were talking about were in Cygnus.
And right now, Cygnus is right overhead now. If you go outside and look straight up, that's pretty much where Cygnus is, I believe.
Yeah.
Maybe a little bit to the west.
Yeah, let's see
A little, if the meridian is a line that an imaginary line that goes like from the north to the south directly, and it passes directly overhead. So that's kind of a reference. And Cygnus right now is just to the west. Cassiopeia is to the right. It looks like an M if you're looking, where it is right now. And, if you see where Polaris is and just kind of circle the sky from where Cassiopeia is to, you see Deneb, or you see Cygnus, which included Deneb.
Yeah.
And Deneb is the brightest star in Cygnus. It's the tail, so it's more to the east of the rest of the constellation.
Yeah. Okay, now this is being a little...
Okay, Lynn, thank you. That was a really good question, because that's exactly what we want people to do, is look up at the sky and find some of the constellations, and then, some of the brighter things you'll be able to see with the binoculars.
Okay. Hopefully it stops trailing now. That's being a little annoying.
Okay, so we're going for 2 minutes?
I'm going to try for 30 seconds.
Okay.
We still haven't gotten a good 30-second exposure.
Modest beginning. Okay. We're going to do a 30-second exposure first, and then follow it with a 2-minute.
We'll see if that works. Equipment is going to be like equipment.
Yeah. We are going to do more star parties in the future, and probably another spectroscopy star party, which is actually our two most popular star parties have been the spectroscopy star party and the light pollution comparison. So
I think we're gonna have to skip this one.
Yeah.
He doesn't want to.
Why? It's just where it is in the sky, or
I think we're getting hit by wind.
Well, it's not.
Or we're not. I don't know.
Sticking up very much.
This isn't very consistent. Okay, we'll just.
Yeah.
I think I can kind of see it though, but.
Mm-hmm.
Yeah, this is not.
This is a faint one. It's a.
The mount's not cooperating with that. Okay, we'll just move on.
Okay. Yeah, that one's a little too challenging. So we're going to move on to the Andromeda Galaxy, which is a perennial favorite, a great binocular object to look at.
And a great target for this telescope.
Mm-hmm. And the galaxy is big. It takes up like 3 moons lined up next to each other. That's how much of the sky it takes up when you see the whole thing.
We'll show where Andromeda is.
Yeah, good idea.
There it is.
So that people can actually find it.
So, you can probably see where Mars is. If you look to the east, It's a big, bright red. Big, bright, and red. And then to the east, if you look at the this is the square of Pegasus, and here's Andromeda. And actually, the three stars in Cassiopeia, they point to where Andromeda is, and that's where you can see it. And
yeah, when you find it with binoculars, you will know it. It does not look like a star. It looks like kind of a cotton candy stretched out kind of elliptically.
there it is.
Yeah.
Let's get 30 seconds on that.
Okay. That's our first really short exposure.
That's 1 second.
That's a 1 second
It's
exposure
bright.
you're going to see.
That's why we can see it naked eye. We're going to look at Mars tonight. Yes, that's that's the end. That's the end treat.
Okay.
So everyone's got to stick around for the end treat.
Yeah, get that Mars bar if you hang in here.
Yeah. It's also because it's a totally... while we're waiting for Andromeda to show up, on that topic, this is the setup we're going to use for Mars. And it's a totally different setup, so...
Yeah, because Mars is quite small in terms of how big it appears in the sky. But like 40 arc seconds or 30.
Yeah, so we need we're going to have to use a bigger telescope.
Yeah, that one's got a focal length of, 1,600 millimeters, plus it has a Barlow lens
we got
that doubles it, so it's effectively like a 3,200 millimeter focal length to look at Mars.
Yeah,
otherwise, if we used the small telescope, Mars would look just like a star. You would hardly be able to tell it's a planet.
Yeah, so we're gonna have a really good view of Mars, hopefully, with this setup.
Right.
We're gonna have to have an intermission for that.
Yeah, well, okay, now we're starting to see something here. Okay.
Satellite, obligatory, and then very nice view of Andromeda. 30 seconds, mind you, with this telescope.
Okay.
Then we've got M32, which is a satellite galaxy, elliptical satellite galaxy of Andromeda. M110, also another elliptical satellite galaxy of Andromeda. And let's go for 120. We want to get really good view of this.
Now you'll notice that you see those dark lanes in Andromeda. They're just like what we saw in Cygnus, the
Great Rift in our Milky Way. It's just these
the dark nebula dust, clouds of dust, swirls of dust that are orbiting the center of the galaxy.
Yeah.
And the question, do we have any satellite galaxies ourselves? In other words, does the Milky Way have any satellite galaxies?
Plenty.
I haven't seen one, but that doesn't mean there aren't any.
There's plenty of them.
Okay.
Two of the two ones that you can see with the naked eye, they're only visible to the southern observers. They're the large and small Magellanic Clouds, and they're visible from the southern hemisphere. And there's many other dwarf galaxies that orbit our Milky Way that are pretty faint, but if you know where to look, you can go and find them. There's one in Leo. There's some in
satellite galaxy.
Yeah, there's
in Leo.
There's one in Pegasus. They're all over the sky.
But the Magellanic Clouds are the big bright ones.
They're the two bright ones you can see with the naked eye very clearly.
And I take it Magellan might have been the one that noticed them or named them or something. Named him after himself? Interesting.
Well, we call him that because he was the one to circumnavigate the globe.
Describe them, I guess.
Yeah.
So, at least you're first European to notice them.
Okay, I think, is this 2 minutes? I don't think so. Chip wants to know.
If the Milky Way is a satellite galaxy.
It's not. It's its own galaxy, but it has a gravitational relation to other galaxies. There's always gravitational interaction. And Andromeda is coming towards us. And eventually, in a few billion years, there's going to be a collision.
Some of the sun could end up being in a satellite galaxy of Andromeda someday.
Yeah, but by then, the sun will be a very different star. Oh, that's really nice. Okay, we can even see some of the outer parts of Andromeda now.
Yeah, you can see how far it extends.
It's a big galaxy. There's some fainter regions around here that we can see now. And the core, if we look at it unstretched, still very bright. So
how dense are the stars in the core of Andromeda, would you say? I mean,
Very.
So what would be, say, a average distance between the stars and the core? Maybe a couple of light years, or?
Well, it's already a couple of light years in our own neighborhood, but there's a lot going on in the core. There's a lot of older stars, and there's a supermassive black hole at the center, and those stars are moving really fast around the black hole.
Okay, so the rotational velocity at the center is a lot different from.
Well, think about it. Like if you're spinning a wheel, the outer parts are going to go the slowest,
Right.
while the parts inside are going to go very fast.
Right, but a wheel is a solid object, so.
Yeah, and I'm just talking about like
yeah.
how like if you're in the outer part of it, that's going at a slower speed than if you're closer in.
Right.
That's the way rotation and tangential velocity.
Right. Well, okay.
Yeah.
But as it rotates, would the outer parts wouldn't be keeping up with the rotation of the center, do you think?
What?
Would the outer part of the galaxy, like, would the whole galaxy rotate once, say, every, I don't know, 200 million years? Or
Yes.
would the whole galaxy rotate in once? So it wouldn't be the center would do it in 100 million
No, like
years.
you think about it. If you're spinning, if you've got the wheel and you're spinning it,
Oh, yeah.
there's a lot of velocity at the center. But
right. But it's not moving as far.
Because there's a greater distance
Yeah.
for the...
Okay. Hey, Roy. Good to hear from you. All right. We got Roy up past his bedtime. That's an accomplishment. Okay. Well, no work tomorrow, right? Okay. Yeah, so that's the Andromeda Galaxy with a 61 millimeter small telescope, but with a pretty sensitive camera.
Okay, I think I get what you're saying. You're saying like if it's on the wheel, since the inner part has less to cover, it's supposed to go slower, right?
Well,
here's the thing.
If the whole galaxy rotates at the same...
So that's the tangential velocity. The problem is it doesn't rotate. It's not a solid body, like you were saying, and because of if you think about it in Kepler's law, it means if you're closer in, your orbital speed is much faster. So you make faster, more revolutions, while the rest of the galaxy it takes longer to make a revolution.
Yeah, kind of like the solar system.
Yes.
Well, I mean, Mercury it makes one orbit around the sun, 88 days. We take 365 days. Mars takes about 2 years, and so on. As you get out there, the planets are taking a lot longer.
Well, that's the galaxy rotation curve, and that's kind of how we figured out the presence of dark matter, because there was a discrepancy, because it doesn't exactly follow what we are supposed to, what we've imagined it's supposed to be like.
Okay, we got some questions. Susan Sandwell, boy, Susan, you're good with the questions. Is the very bright center of Andromeda gas or
It's
stars?
It's a lot of stars. Very much older, lots of older stars. And it's not one star. There's not one big star. It's not. Stars don't outshine galaxies unless they're a supernova. Yeah.
Yeah, and then there's the black hole at the center.
Yeah.
Yeah. Okay, Burning Man.
He had the same question.
Okay.
I just answered that.
Okay. Yeah.
Okay, so that's the Andromeda. I think we can go to double cluster now.
Okay, if any more questions about Andromeda, fire away, but we're going to move on to the double cluster in Perseus, which is also we're in an area that's kind of in the northern part of the sky, not so far north that they're close to the North Star, Polaris, but they're in that area of the sky. And what we've just looked at, the galaxy Andromeda and the double cluster, they're also to the east right now. They're rising.
Yeah. Andromeda's over here, and then the double cluster.
So they're in the east. Yeah.
The double cluster is right over there.
Yeah, they're in the northeast. And the double cluster that we're going to look at in a second with a small scope, it's going to be a little bit like if you looked at it with binoculars. And it's a great object to look at with binoculars. Never get tired of looking at it.
You can say the same for a lot of objects.
Mm-hmm. And you can see it with your naked eye too, which helps them to find it with the binoculars.
Okay, we should be there now.
Mm-hmm.
What camera are you using? That's the
We're using a ZWO ASI 294 camera.
294 MC.
MC,
Color.
okay. Color, right. There's a mono version and color version.
1 second exposure, pretty nice
That's
already.
a 1 second exposure, okay.
Let's get this one's it's a star, so we don't want to get trails on this object.
Mm-hmm.
So we'll take 20 seconds on that.
Okay. We don't need that long either. This is a cooled camera. It has a fan and a thermoelectric cooler to keep the sensor cold, which lowers the noise, and it's better for the sensitivity, and it also keeps it at a consistent temperature.
Okay, here we are. There's a bit of do we have the UV IR cut on that?
Yeah,
That's
I
good.
believe so. Yeah.
Okay.
Yeah. Why, it doesn't look like it?
There's chromatic aberration.
Yeah. Mm.
It's a little purple.
Mm-hmm.
Okay, this is the double cluster.
Yeah, I noticed that a little too when I used it.
Yeah, we'll have to deal with that later. Okay, yeah. So you find the double cluster by. So if you're familiar with the constellation Perseus, it looks like this. It's southeast of Cassiopeia, and it's northwest of Perseus, and it's right between there. And if you're in dark skies, you'll notice there's like a fuzzy patch between these two constellations, and that's what the double cluster looks like visually in dark skies. So you just have to point the binoculars there, and then you'll see this very rich cluster of two different clusters of stars.
Yeah, really easy to find and well worth it. I mean, it's really a knockout in binoculars.
Yeah.
And it's pretty much a knockout in the 61 millimeter telescope.
Well, we could go a little more focal length. It's a very wide field view of the double cluster.
Mm-hmm.
Yeah.
So those two clusters, we call them open clusters. There are two kinds of star clusters, basically. The open clusters, which are, the stars are a little more spread out, and then globular clusters where they're like a ball of stars with some out peripherally as well.
Okay. Are we visiting the Tulip or Crescent Nebula? No, those are both smaller objects, so they wouldn't really work with this focal length. And also, we've done the Crescent before, and the Tulip's a bit faint. Yeah,
Okay,
so we're not doing those two.
Susan wanted to know if we could repeat where to find the double
we just
cluster.
did.
Okay.
We answered that
I think she
question,
probably
hopefully.
got it, hopefully, yeah.
If you didn't, let us know.
Yeah. One thing I just want to mention is to use a planisphere. A planisphere is a very cheap little gadget. Costs $12. In fact, the Julian Dark Sky Network, we sell them, and they're a great way to learn the sky. It is a wheel. You turn it according to the day of the month and the time of night, and it will show you where a lot of these objects are. It definitely will show you the constellations and the brightest stars. It's been used for decades, and it's a really good little tool to get a hold of.
Yeah. Okay,
So
I think...
if you're interested, just go to the JulianDarkSkyNetwork.net, and we have an online store and a lot of stuff about light pollution and practicing good lighting. Also, I should mention, if people want to join the Julian Dark Sky Network, which means just to send in a minimum of $10 a year dues, we will get you a nice orange light bulb which you can use as a porch light, to replace those nasty white lights that produce a lot of glare and contribute to, light pollution of the night sky.
Okay.
So that's something new, but just wanted to mention it.
It's time.
It's time. Okay, it's Mars time.
The
Okay.
final treat.
All right, we know everybody's been waiting to go to Mars because it's a cool place. It's kind of a little bit Earth-like in some ways, and but we're going to have to disconnect from that small wide field telescope and plug into the.
One last question: are the double clusters gravitational corrected? I think the answer is yes.
Mm-hmm.
I think so.
Yeah, pretty much all star clusters, globular and open clusters, gravity keeps them together. They usually have a common origin too, and are similar in their type, their spectral type, and their age.
Okay, let's head to Mars.
Yeah, one of the really nice clusters is the Pleiades, which will be coming up. I guess it's already up, but it's not very high. It's still pretty low, but it's coming up. If you stay up another hour or two, it's rising in the east. It's also called the Seven Sisters, and it's just a fabulous binocular target, and really easy to find. It looks like a little tiny dipper, actually, kind of like a miniature of the dipper, of either the Big Dipper, the Little Dipper. You could call it the Mini Dipper, or the Seven Sisters, which is part of the mythology. Is that the Seven Sisters are eternally pursued by Orion the Hunter, and he's just enthralled with them, but he can never catch up with them. So, okay, well, just if everybody could hang in there, we will be heading over to Mars as soon as we get the other telescope connected, and Vivek's doing that.
We'll have to get the other. Oh, there it is. Got it.
Oh, yeah. The
small intermission.
Yeah, we're going to...
When will the new space telescope be launched? If you're referring to James Webb Space Telescope, in 2,000 years. That was a joke.
Yeah, at the current rate.
It's supposed to be 2021, but it has a history of delays.
Yeah, there have been a lot of delays.
And now coronavirus has stalled a new delay. And there's probably some other delay I haven't heard of too. So
yeah,
it's a very big project. It's very expensive, and it's so you have to make sure it works properly, because when you launch a space telescope, you can't send, especially when we're sending this one to the L2 point. Yes. So we cannot maintain it. We can't fix it like we fixed Hubble numerous times.
Yeah, it's going to be in a more an orbit further out from the Earth than where the Hubble telescope is.
Where astronauts haven't gone.
Yeah. Now, the Hubble telescope, of course, did have some problems, and there was, people went up there and were able to fix it and make it work well. So they're being a lot more cautious about launching this one. But it's going to be something else. It's definitely going to...
It's an infrared telescope for the most part.
And it's going to, from what I understand, it's going to enable us to see much farther out in distant parts of the universe.
That's what infrared does.
Yeah, and what that means too is, because the further you go, you're looking back in time. So we're going to see some of the early universe, and that will tell us a lot about the formation of the universe, the known universe, I should say.
Okay. It's time for. Let's see what we've got of Mars.
Okay, so we're gonna see if did you see if it was centered before you took the eyepiece out? Okay, good. Because I noticed it drifted a little bit when I looked.
Well, that's the tricky part, isn't it?
Okay, this is where we're kind of upping our ante here by trying to show you Mars on the fly, because Mars is very small, and we're magnifying it a lot. So that also means then that we have a very narrow field of view, and focusing is really critical too, to be able to see anything on Mars. We don't want to just show you a kind of a fuzzy red disk. But
See?
if you,
Start hunting for Mars.
yeah, if you go to the, I think we have on the JDSN.
There, got it.
Okay, got it. Okay, there. Wow, it looks huge.
It's out of. It's very out of focus.
Out of focus. Okay.
People can see that, right?
Yeah. Okay. It looks like a little bit of a donut that's been invaded by amoeba. Okay, that's it. But we're gonna bring it into focus. Okay, it's getting better. You're getting there. Okay, it's getting smaller.
We're gonna be doing the standard Mars processing too. So
Okay.
it's right over a decimal. We don't want that.
Yeah. Okay.
Okay.
You want me to give you some feedback, or are you able to see it?
I can see.
Nope, it's out. Okay, back in. Ooh, that looks pretty good.
Okay.
Okay, we're getting there. Okay. Oh yeah. Okay. Yeah. That's Mars, folks.
Let's.
Pretty decent image for on the fly. Now, if you're wondering why it's jumping around and sometimes the features are clearer, that's atmospheric turbulence, which is, for viewing planets, a big issue. And we have tricks to overcome that turbulence when we're imaging the planets. And
I should have brought my. Never mind. Okay, let me. Focus is very critical for planets.
yeah, Vivek is working the focuser to get it as sharp as we can.
Usually, planetary imagers use motor focus, but we don't have that available right now.
So one of the tricks I was talking about is to take video of the planet, and then what happens, you call this lucky imaging. Maybe every 5 frames or every 10 frames, there's one that's really sharp because the atmosphere is still for a split second. So you get enough of those, and then you stack up the good ones and discard the blurry ones, and then you get a good image.
Okay, we don't need a 1 hour.
No,
1 minute.
1 minute's worth.
I'll do 2 minutes.
Oh, are you gonna do
We're gonna do the entire process.
Okay, we're gonna do a on the fly stacking.
Well, not on the fly. It's just gonna be regular stacking.
Okay. But it's gonna be lucky imaging.
We're just gonna be imaging. Get a nice Mars photo.
Okay, what region of Mars is that dark area?
I think that's it's not Tarsus. It's hard to see from this image. I recognize it. It's a little. I think west of Syrtis Major.
Mm-hmm.
I can't recall what it was called. You know who would know? Stellarium would know.
Mm-hmm. Okay, let's look at Stellarium. A little pocket reference, digital pocket reference.
Yeah, it just knows craters. Okay, Hesperia and Acidilia planitia. Okay, so that. Okay, I get it now. So this is Hesperia, and that's the orange part above it is Acidilia planitia.
Mm-hmm.
And we're just taking 37 seconds more.
Okay.
Then we're gonna stack it and process it.
Okay, so we're gonna actually take the images that are being captured right now and turn them into a better image, higher quality image.
We're at 246 frames per second, if you noticed. 246.
Mm-hmm.
So we're going blazing fast.
Yeah, so every second there's 246 images being.
Yeah, we've collected 28,000 frames, so it's gonna be a lot of processing. Oh, okay, approximately 300,000. Okay, so we've captured that.
Okay.
Now we can open. We
So
can open.
every frame is not going to be stacked, though. It's going
We're gonna only stack 30% of those. The best
to
30%.
the best 30. So the best 30% out of those, in other words, 70% of the images are going to be discarded, and the best 30% are going to be stacked.
Okay, there it is. We've loaded it, and I needed to light its color.
So how long is that going to take it to process? Would you say?
Okay. I don't know. It's gonna take a while. So you have to bear with us. Zoom, zoom, zoom. Okay, 200%. Okay, let's analyze that. Well, that's doing its work. You can try to see if you can catch any detail on that.
Okay. So that's just
And
as
if
it
you-
was captured, right?
If you notice, there's a blue bit on top and red bit on the bottom. That's due to the atmosphere. So that
Mars's atmosphere.
No, our atmosphere.
Our atmosphere.
It's atmospheric dispersion.
Mhm.
So it creates this lateral chromatic aberration due to the fact that the light coming through the atmosphere kind of acts like a lens.
Mhm.
So the blue light has a different path.
Prismatic or.
Yeah,
Mhm.
that's something we correct with the special instrument called an ADC, atmospheric dispersion corrector. It's what a lot of planetary imagers used, and we used it for the planetary star party. But Mars is pretty high, so we don't really need it that badly for this. Okay. This is taking forever.
Okay. Well, this software is working on this, and it will produce some interesting results. We'll see. And I imagine most of you who are watching know that Mars is, we're right around the opposition of Mars, which is the point when Mars, Earth, and Sun are in line with each other. And more or less, this is when Mars is the closest to Earth.
Yeah.
So it's a good opportunity to observe
Well,
it, to image.
The closest approach was on October 6th.
Mhm.
That's when Mars was closest to us.
Okay.
But the opposition, which means when Mars is basically in a straight line with us with the Sun, that was on October 13th. So we're only just 4 days. We just been only 4 days. So
Since the
Mars is
opposition.
still there waiting for us.
Now with binoculars, you're not going to see much on Mars. You really need a
It's
telescope.
actually if you have pretty big binoculars.
Yeah. Okay. Like.
You have
the
pretty
kind that
good,
you need a
big
tripod.
sharp binoculars can actually see stuff on Mars, but yeah, you want big fat aperture to see.
You need a tripod if you have big binoculars.
Yeah, but the most important thing is the seeing. If the atmosphere isn't with you, then your images are not your image or your visual observations are not going to be.
Yeah, and maybe we could talk about that for a minute because seeing is not equal to dark skies. You could be in a very dark sky place and the seeing could be bad. You can be in the city and it's not at all dark, but the seeing could be good. It depends on a lot of things that influence the stability or instability of the atmosphere. So, you can live in the city and do some pretty good planetary imaging.
That's
what
I do.
Which is what Vivek does, yeah.
I mean, you use one of the Mars animations for the advertising, right? Yeah, that was taken from San Marcos.
Yeah, right. That was on the official Julian Dark Sky Network Facebook. There is one of Vivek's. It's an animation,
I think
time lapse.
Yeah.
Or animation of Mars where there's quite a bit of detail.
I think I can. I don't think I have it on this computer. Actually, let me see if I can show that.
Okay.
Oh, well, let's wait for
maybe
this.
we could, show that while we're waiting for the genius software to do its work.
Yeah. Okay.
Okay, we're going to bring up one of those. And you'll notice that in the animation you see a little bit of rotation of Mars because during the period that the images are taken, Mars is rotating.
I'm trying to place. Okay, we did that. Now, stack. Okay, now it's gonna stack. Mars is still.
Oh, okay, it's ready to stack.
It's stacking.
Okay, so the software already has selected the best 30% of the images, and now it's stacking
And
them
Mars
together.
wants to go away.
What's it
I'm
doing?
back.
Huh?
I'm bringing it back.
Okay.
Okay.
So are we looking at it live, or is this?
Huh?
Are we looking at still a live image?
Yeah, that's his
Yeah.
Mars.
Yeah.
We're stacking.
Yeah, but it's in the meantime it's stacking.
Yeah. Well, let me get the.
Okay, appreciate everybody's patience. So, you know.
There we are.
Yeah, okay, well, okay. In just a minute, you're going to see Vivek's
That's from.
finished product.
Well, this is not the same setup. This is with the bigger.
This is with a bigger telescope.
Yeah, C11.
11-inch telescope. The one we're using is an 8-inch telescope, a reflector type of reflecting telescope, which means its basic objective is a mirror that's 8 inches in diameter. And the one on the right was done. That's a finished sequence of Mars done with an 11-inch telescope.
And with the monochrome cameras with filters, so
okay.
It's a much more planetary oriented setup. What we have here is a much more on the fly setup. So we're not going to get anything close to this finished project, but we'll see.
And that's the ice cap or the southern.
Yeah, that's the southern polar ice cap. It's on its way.
Okay, well, our stacked image
A full
is
10
coming.
minutes of the star party will just be waiting for this.
Okay, what is, let's see, Eleanor Schubert can't see anything in Carlsbad sky now as heavy fog rolled in. Yeah, you got that marine layer that we hear about all the time. It does occasionally sneak up to Julian even, but when it's just out there, consolation prize is imagine how much darker the sky is in Julian because the marine layer is smothering that light pollution that all those more coastal communities from everything from Oceanside to Poway, Escondido, and of course city of San Diego is throwing up in the sky to keep you guys from being able to see the Milky Way. But that marine layer kind of smothers it like a blanket for us up here, and the sky does become darker.
You're really selling the upside there.
Yeah. Well, that's when you want to get in your car and come out to Julian with a pair of binoculars. And there's a great place, the Vista viewpoint right off the 79, just a little bit south of the town of Julian. There's a place where you can pull off. It overlooks the desert. Park your car. There's no lights around there. Get out the binoculars. Watch the meteor shower, the comet, or the Milky Way. Just sweep the sky with your eyes or your binoculars. That's definitely highly recommended for a weekend getaway. Okay, now is that our stacked image we see there?
No.
Oh.
It's still 42% through image alignment.
Okay.
It's still doing its rounds. Intermission 2.
Okay. Yes. We don't mind if you make popcorn.
Technically the star party should have ended, but we're just waiting for this stacking. But yeah, there's, again, people even see, that's the setup.
Yeah.
This is literally what we're
That's
using
inside
right
our little observatory at Curiosity Peak in Julian. It's a little 12 by 14 building. The roof rolls off naturally. We have to have some way to get rid of the roof when we want to look at the sky. So the roof rolls off to the north, leaving just the walls and the telescopes peering up into the night sky.
Okay, well, is it done yet? Come on. Oh, so close.
And if you want to see some of our images and...
It's done.
Okay, it's done. Okay.
Okay, now we have to do the processing. So we're gonna have fun with that.
Okay. Oh, are you gonna do a little cosmetic surgery on the image?
Well, no, we have to do. If you've seen the planetary start party, you've seen all of this already.
But not of Mars.
Yeah, but it's the same process.
Mm-hmm.
But I just have to fetch out.
Okay, now we're going to use Pix Insight, which is an amazing piece of software.
We're going to find the stack.
Has so many tools in it. I don't know if anybody knows how to use all of them except the creators of Pix Insight.
Okay, we've got a nice little Mars stack.
Mm-hmm.
And if you noticed, it's quite blurry.
Okay.
So we're going to use this to fix that.
It's going to get sharpened up. Oh yeah, thank you, VJ, for mentioning this. We are very interested in getting suggestions for future virtual star parties because we do want to keep doing them. This is, I don't know, how many have we done now? About 9 or 10?
Okay, there it is.
Okay, wow. Okay, in just a second you're going to see a finished image.
They've already seen it.
Okay. Yeah, so that's you know, it's nothing fake about it. It's just a product of a lot of images being stacked together so that the details are brought out.
The seeing isn't very good, which is why it's a little.
Yeah.
But it's the best we've got from. It's pretty. Considering the circumstances. So. Obviously, it's not.
And the polar cap.
It's not that, but
and the polar cap is it's reversed from the other image, right?
Yeah, it's just to rotate 90 degrees. I can.
Mm-hmm.
Let me do that really quickly.
90 or 180?
Huh?
Probably
180. Yeah, you're right. 180. There we are.
Okay.
Now it's more comparable to that.
Yeah.
Actually, this is not the same region though.
But yeah, right. We're looking.
Let me get a different animation in the same region. Okay, there.
Okay. Mm-hmm.
That's more comparable.
Mm-hmm.
There we are.
Oh yeah,
Same
that
region.
was really nice. So you can tell the seeing was better when besides using a larger telescope.
The seeing tends to be better in San Marcos than it is in Julian.
Yeah, how about that?
Well, in this part of, on this hill,
Julian,
on this hill, the topography is very important. So being on a hill is actually not good for
seeing, for the atmospheric conditions.
Yeah.
And we're also very close to the desert on this side of Julian.
So yeah,
that affects it too.
There's a comparison. If you do the light pollution comparison, here's a very unfair comparison of Mars.
Yeah, it'd be nice. Sometimes though we do have good seeing here. It varies. It's not very predictable either.
It's not a very fair comparison. Let's be honest here. This one's a color camera with the smaller telescope in Julian.
Yeah.
That one's a monochrome camera with a much bigger telescope. So, yeah, but it is what it is.
Yeah. Now, what difference does it make in its color? Well, color camera doesn't have as high of a resolution as a monochrome camera because with a color camera, you have a matrix of 4 pixels, and
they have filters on them.
They have little tiny filters
that create the color you see.
But you know, instead of so each pixel is only picking up one color, one wavelength. So that whole little complex of 4 is not going to have the resolution.
Also, the color on a monochrome camera very counterintuitively is better than what you get on a color camera
Mm-hmm.
because you can much more better color balance. So you see a lot more of the
Mm-hmm.
detail on Mars and the color variation, and the color camera doesn't really show that as well.
Yeah.
But
So with a monochromatic camera, you're using filters and you're shooting one filter at a time,
yeah,
and then you assemble all the data together from the different colors, usually red, green, blue, and then they get combined.
another thing to note is this was taken like a month ago. This was when it wasn't in opposition, so
Mm-hmm.
it's a different. It's a,
So
it's
it's
a little more.
smaller, yeah.
It's gibbous.
Mm-hmm. Okay, yeah, it's not a full Mars. It's a
But yeah, this
gibbous
is
Mars.
a Mars to end on.
Mm-hmm.
It is, so
Yeah, planets show phases just like the moon, especially the inner planets, Mercury and Venus, but also Mars
yeah.
to a lesser extent.
Okay.
Yeah. All right. Well, I guess that's about it for tonight.
Yeah.
Okay. Any last questions or comments or suggestions? You can email us suggestions and comments too if something comes to you later. Just send it to juliandarkskynetwork@gmail.com or curiositypeak@gmail.com. Either one, we'll get it, we'll ponder it, and we'll appreciate it. So thank you for joining us from Julian, and it's great to be with you from everybody. Okay.
All right. Yeah. And okay.
Yeah. And Lynn wants to know when the next star party is. We're not sure. We're going to figure that out. But I really encourage you, if you like this, on our channel, you can subscribe. If you subscribe, then you will automatically be notified about the
Yeah.
upcoming star parties.
And also we'll announce it before on the other places.
Yeah, we also
the
put it on
Facebook.
official Julian Dark Sky Network on Facebook and the JulianDarkSkyNetwork.net, the website.
Yeah. Most likely the next one will be the spectroscopy star party, and this one will be with the big. Last spectroscopy star party we used a small little grating that doesn't show a whole. That's not very high resolution. So this next one will be a little more even higher notch with the actual spectrograph.
Mm-hmm.
So,
which is a little bit bigger instrument.
Yeah, so we'll have to decide
considerably bigger.
We'll have to decide the date for that, but yeah, that's probably the next one.
Okay, all right. Well, again, thank you, everybody. We I hope you guys enjoyed it as much as we do, especially when we hear from you and we know you're there. It really kind of fires us up.
Okay.
All right. Good
Bye.
night. Stay safe.